important is the Venn diagram in our real-life situation? It is provide a clear way to express the relationship between entities, and particularly where two more things and the Venn diagram is simple make the data become more easier to visualize, which is why they commonly used in presentation and report. The application of three-set Venn diagram. So let's start with our question. An interview of 100 students showed that 31 took math, 42 took English, 28 took history, 6 took math and English, 9 took math and history, 10 took history and English, 4 took all three subjects. So we're going to take all that information and organize it into three-circle Venn diagram. So the first thing that you do is start with the region where all the three circle overlap, and if we look to the information, there were 4 students who took all 3 subjects. So into the region, we will place 4 in the center. So now everything inside of the circle is going to be affected by that because you have already 4 in all 3 circle. So the next step is to focus on 2 circle region. That would be math and English, also math and history, and then English and history. So we'll start with the math and English. 6 students took math and English, so we have to subtract 4 already in the circle, and so 6 minus 4, that would give us 2. So 2 students took math and English. So next, we will focus to math and history. So there were 9 students into that region, so we'll have to subtract 4, that would give us 5. So 5 students took math and history. Next, we're going to focus on English and history. So there were 10 students took history, so minus 4, that would give us 6 people into that region. So now we're done with our 2 circles. Now we're going to is the only area, so we'll start with the math. In the math, there were 31 students. So as you can see, there are already numbers into the math region. So there were 2, 4, and 5. So we're going to subtract it to 31 students. So 31 minus 11 equal to 21 students. So 21 students took math only. So we're going to do the same in the English subject. So there were 42 students took English only. So we have numbers into that region. So there were 2, 4, and 6, and equal to 12. So we're going to minus 12 minus 42. That would give us 30. So there were 30 students took English only. So we're done with the English. So let's proceed to history. So we have people already in history. We have 4, 5, and 6 equal to 15. And there are 28 took history. We're going to subtract 15 from 28 will give us 13 took history only. So right, so we got our Venn diagram partly. As you can see that the total amount of the student is only 80. So the other 20 students that are outside who didn't take any subjects.
Hey everyone, so we will gonna discuss a certain topic about a Venn diagram problem. So let's begin. So consider 3 sets A, B, and C, where set A represents students who play football, set B represents students who play basketball, and set C students who play tennis. So we will gonna identify the overlapping areas and determine the overlaps between sets, the intersection of A and B, the intersection of B and C, the intersection of A and C, and the intersection of sets A, B, and C. So we're gonna input the data into the Venn diagram and represent each set with a circle and the intersections with an overlapping on them. So here's the Venn diagram, and we will gonna analyze the diagram to observe the areas where circles overlap to understand the relationships between the sets. So the set A represents the 20 students, and the set B represents the 15 students, and the set C represents the 10 students that was mentioned earlier. And then this was the intersection. So we were gonna tackle the problem sets here. That the first question was, how many students play only one sport? We got football, that the cardinality of the set obtained by excluding the elements that are in the union of sets B and C from set A is equal to the cardinality of A minus the cardinality of intersection of A and B minus the cardinality of the intersection of A and C plus the cardinality of the intersection of A, B, and C. And this is the final answer. So for the basketball, the cardinality of the set obtained by excluding the elements that are in the union of sets A and C from the set B is equal to the cardinality of B minus the cardinality of the intersection of A and B minus the cardinality of the intersection of B and C plus the cardinality of the intersection of A, B, and C. And this was the final answer. And for tennis, the cardinality of the set obtained by excluding the elements that are in the union of sets A and B from set C is equal to the cardinality of C minus the cardinality of the intersection of C minus the cardinality of intersection of A and C plus the cardinality of the intersection of A, B, and C. And this was the final answer. So moving on, we have the sum of the cardinalities of the intersection of sets A, B, and B and C, and A and C minus the 3 times the cardinality of the intersection of sets A, B, and C is equal to the result of evaluating the numerical values of A. This was from the intersection A and B. So 5 from the intersection B and C, and 3 from the intersection A and C. So we will gonna have this final answer here. So technically this was the solution. So last number, the cardinality of the intersection of sets A, B, and C is equal to 2. That's all. Thank you.
Hello everyone, my name is Kennedy Igagamao. I will report you about Venn diagram involving 3 circles. A group of 62 students were surveyed, and it was found that each of the students surveyed liked at least one of the following 3 fruits: apricots, bananas, and cantaloupes. So we have 34 like apricots, 30 like bananas, 33 like cantaloupes, 11 like apricots and bananas, 15 like bananas and cantaloupes, 17 like apricots and cantaloupes, and 19 like exactly 2 of the following fruits: apricots, bananas, and cantaloupes. So we have the Venn diagram. So let's proceed the equation. I put the middle of the x. If this is x, it has to be 21 minus x. It has to be 18 minus x, and lastly 19 minus x. I'm going to set up an equation and solve for x. So we have 21 minus x plus 18 minus x plus 19 minus x is equal to 22. 58 minus 3x is equal to 22. 58 minus 22 is equal to 3x. 36 is equal to 3x, and lastly x is equal to 36 divided by 3 is equal to 12. Now let's move forward the last equation. So x should be at 12. And next we had this time was 21 minus 12. This has to be 9. We have 18 minus 12. This has to be 6. We had this 19 minus 12. This has to be 7. And we subtract 7, 12, and 19 from 39. This has to be 11. And we subtract 50 to sum of 9, 12, and 6. And we are going to get 23. And lastly, we subtract 6, 12, and 7 from 39. And we get 14. Let's move on to the next question. So we have 4 questions of the following. Okay, how many students like apricots but not bananas or cantaloupes? So the answer is 11. How many students like cantaloupes but not bananas or apricots? The answer is 14. How many students like all of the following 3 fruits, apricots, bananas, and cantaloupes? The answer is 12. How many students like apricots and cantaloupes but not bananas? The answer is 7. That's all, and thank you and God bless.
Hey, good day to everyone. My name is Jazz, and I am going to present my part of the problem. So, for our Venn diagram, we have this example. So, for our example, we have a survey of a faculty and graduate students at the University of Florida. So, in their film school, they revealed the following information. So, 51 admired Mo, 49 admired Larry, 60 admired Curly, and then there's 34 that admire Mo and Larry. Next is 32 that admired Larry and Curly, 36 that admired Mo and Curly, 24 that admired all of the Three Stooges, and only one of them that doesn't admire any of the Three Stooges. So, for our question, we have 5 questions. For the first one, how many people were surveyed? Next, how many admired Curly but not Larry nor Mo? Next is how many admire Larry or Curly? Afterwards, how many admire exactly one of the Stooges? And finally, how many exactly admired 2 of the Stooges? We have multiple steps. First of all, we have to do our Venn diagram. So, for our Venn diagram here, we have 3 circles. One for Mo, one for Larry, and one for Curly. And the next is a box, aka the universal parts. So, the next step is that we add all of the 24 people who admired all of the Three Stooges. So, we add it on the middle, where all of the circles meet. Next up, how many of those that doesn't admire any of the Stooges? Well, we are going to put it outside the circles. Why? Because they, well, are not included for the fact that they really don't like any of the Stooges. Next up is, there are 36 people that admire both Mo and Curly. So, what are we gonna do? Now, the thing is, what we are going to do is that we minus it onto 24. And then we add 12. Because they meet up together. Because they count as like the people who liked both Mo and Curly within the middle. So, we add 12 between Mo and Curly at this point. Same thing we do with Larry and Curly.
Good day everyone, I'm Dominic B. Garcia. For today I will discuss to you the application of T-set Venn diagram. So let's proceed for our question. So a survey of 125 students showed that 68 wish to travel to Hawaii, 53 wish to travel to Las Vegas, 47 wish to travel to Disney World, 54 wish to travel to Hawaii and Las Vegas, 26 wish to travel to Las Vegas and Disney World, 23 wish to travel to Hawaii and Disney World, and lastly, 18 wish to travel to all 3 destinations. So we should keep in mind in drawing or illustrating our Venn diagram, we should understand its concept and what's inside our Venn diagram, so that we can easily identify the value what's inside of our Venn diagram. So first here, as you can see, I labeled my circle. So H stands for Hawaii, D stands for Disneyland, and L stands for Las Vegas. So let's proceed for our data gathering for our diagram. So here, our VD is illustrated. So first, we should get the middle value of our Venn diagram. So as you can see here, 18 wish to travel to all three destinations from the last statement. So 18 should be in the middle of our Venn diagram. So after that, we should get the value of our intersections. So what are the intersections here? Hawaii intersection Las Vegas intersection Disney World, and Hawaii intersection Disney World. So to get the value of Hawaii intersection Las Vegas, so we should subtract 18 to 34. So 34 minus 18 is equal to 16. Same process here from the Las Vegas intersection Disney World and Hawaii intersection Disney World. So 26 minus 18 is equal to 8. And lastly, 23 minus 18 is equal to 5. So let's proceed. So 68 we should travel to Hawaii. So to get the value of this, 68 is subtracted by 39 is equal to 29. So how come 39? So as you can see, I get the value I just added from the 16, 18, and 5. That's why I get the value of 39. So 68 minus 39 is equal to 29. Same process here from the travel to Las Vegas and Disney World. So 53 minus 42 is equal to 11. And 47 minus 31 is equal to 16. So after we get the value inside our Venn diagram, we should get the value outside of the Venn diagram. So 125 in total minus 103 in the circle. So I get 22 value on the outside. So after we get the value of our Venn diagram, we can now answer these questions. How many did not wish to travel to any of these destinations? So as I mentioned earlier, I got 22 outside the Venn diagram. So I put 22 here. 22 match for did not wish to travel to any of these destinations. So second question, how many wishes to travel only to Hawaii? Simply 29. How many wish to travel to Disney World and Las Vegas but not to Hawaii? To get the value of these, you should identify what between the Disney World and Las Vegas because they are intersected with each other. So what are the value between the Disney World and Las Vegas? Simply it's 8. How many wish to travel to Disney World or Las Vegas but not to Hawaii? So as mentioned here, Disney World or Las Vegas but not to Hawaii. So there should be a relationship between Disney World and Las Vegas and the value between them. So I add 11, 8, and 16. That's why I get the value of 35. And lastly, how many wish to travel to exactly one of these destinations? Simply, I just add the value from the Hawaii, which is 29, Disney World, 16, and from the Las Vegas, I got 11. So I add these 3. That's why I get the value of 56. So thanks for listening. I hope you learned something from my Venn diagram application. Thank you.